Okay, so what I'm going to do today, I will do two things. The first thing, I'm going to finish the JSON programming. So last time I showed you second of code that you can access from a C++ object, recursively generate JSON that to represent a interaction, a conversation that representing a pretty much social media. How do you actually use JSON to represent the information? How do I be able to create a JSON automatically using program to do that? So that is called JSON programming. How do you actually to generate JSON? So I'm actually going to do a little bit today is that, well, how do I actually read the information from a JSON object using C++? Means that this object is already a JSON column value. So if you remember what I showed you last time, let me actually go back to here. To my terminal screen. Going to, I think I have the other window. No, not this one. I have just too many windows for me to. Okay, I will just use this one. Fine. Program. So this is what I showed you last time on the dump.j. So inside dump.j, let me make this a little bit bigger in font so you can see better on the screen. Oh, get the wrong directory. This is the reference implementation. I want to show you the solution. Yeah, this is what I want to do. Okay, so this part, if you remember, I create a pointer to an object called result pointer, which is using new JSON column value. So in C++, JSON column value, this represents a JSON object. And once I have the object, how do I, so the direction about dump.j, or direction I showed you last time, is how do I push information into this JSON object? So this whatever information I have in the C++ object world will now represent as a JSON object world. So remember, object-oriented, it's an object, but we use different programming language or different notation to represent the same information. So we have been developing up to this point is pure C++ object until we start looking at homework 5, which now we're actually clashing with another object world. I mean, you can imagine how important that is, because in this world, we are going to have objects, but we're going to have a different representation. And then we need to do a unambiguous one-to-one translation from one type of object to the other type. For example, if you can do C++ to JSON, then essentially, if somebody developed from Python to JSON, then basically C++ can talk to Python through the media. So JSON become in today's industry standard, almost become like the common platform for everybody transform their information into JSON. And then once you have that, you can actually convert it to whatever you want. So dump.j is essentially doing that first part is how do I push C++ information into a JSON format? So that's why how I push it, it's actually very simple. But the beauty about this JSON programming is that it's powerful and yet is very easy because people already developed this interface nicely, very naturally. So if I want to put a key value pair, essentially what is JSON? It's key value pair. So I actually just take this key and then just shuffle the value. So to push in, you tell me what the key is, and then I shuffle in. Okay, that's key value pair. And over here, you could be anything. This value, it could be a basic type. It could be null. It could be anything. The compiler, the library will pick it up. Or it could be a object. Because you think about this part is a person object dump-j. Means that the result of that dump-j is a person object, has a name and, avatar name and vsId, those two key value pair, and encoded as a JSON object. So essentially, I'm actually push the key value pair where the value itself is a JSON object. Okay, so that's pretty much very standard about how you can use this interface to actually shuffle information into a JSON object. The only part, as I mentioned, is a little bit tricky is array. So how do you actually shuffle the array into a JSON? The JSON has array that's represented by bracket. So the way you do it is actually also very naturally. If you think about array, it must have some kind of index. So they also have an index. By the way, in the JSON, they don't have an explicit index in the format. They just keep adding, and they're expecting whoever extract that will actually count to access the element. So that is, when you read the JSON, you didn't see the index, but the index is implicitly by the order of the element is already there. So what you do with the array, this one, you see that this is actually a JSON object. It's a JSON value. Let me see, where's the JSON C reactions defined? JSON C reaction itself is an object. Okay, so I didn't define it as array. I defined it as a JSON object because JSON object could be anything. Could be basic type, could be object, could be array. So whenever I define this universal JSON column value, I'm defining an object. I can actually use it whatever I want. So once I define the JSON C reaction, by the way, JSON C, just to let you know what that C stands for. C stands for comments. So it means that when you can have a reaction to the original post, original article, sorry about that, for some reason I'm breathing has some issue. So you can actually make a reaction to an original post, but here this variable specifically is for comments. So that's why it's called JSON C reactions. So I declare a variable called JSON C reaction and see how I use it. I just essentially using it as an array. This is line. I just have an index and I said JSON C reaction I, which I is the index I control by my C++ program. And then I shuffle the pointer. What is this pointer? Each of the pointer is what? Is a is a reaction dump-j. It's a reaction dump-j. So I basically take comment as a reaction vector, and then take the vector one by one, and each of them is a reaction, and I call dump-j for that reaction. So that is a reaction JSON representation. So I'm actually converting. So let me just tell you this part. This reaction I is the C++ world of the reaction array. So I extract one by one. Whenever I take one out, I actually convert it using dump-j. So dump-j is a converter. So you convert it to a JSON object. And then I actually save it as this pointer. And then I just put that in. I mean, potentially I can just directly put this over here. That's okay. But the only thing I didn't do is because I want to delete it. I created, I know that pointer I have to just like a malloc and free, I have to delete it. That's why I use this one. If I don't care about memory for some reason, which I shouldn't, then I potentially can just directly assign this into here. Okay. Okay. By the way, just a side story. When I first developed this program, pretty much as every single software project, that initially we always have bugs or memory leak, especially for C++ programmer. You need to remember to delete. So I have to check everything to make sure that every piece of memory will be free whenever it's no longer needed. And that's very critical for a system like this, because this potentially need to handle one post with 400,000 comments and about 20 to 60 million reactions. And you can imagine that if the system has just a little bit leak somewhere in the code, it's going to make the server very unstable after a while. Okay, so this is just very quickly to recap what I did last time. Is about how to do this conversion from C++ world to the JSON world. So, okay, the next few minutes, I'm going to show you a segment of code, which is actually doing the other direction. Means that if you give me a JSON value, how do I actually push in to that's, of course, the program called JDOT, but I'm going to first tell you about JSON programming, just as simple as like this. Let me pick something which is I know is pretty complete. Okay, I know this will work. All right, so I'm going to use again. I'm going to use comment.cpp. So you can see now I have something called JDOT. So homework 3 or homework 4, 5, actually, sorry. Homework 5, you actually only have done J, you don't have JDOT. So now when you develop further, you're going to create another function called JDOT. So you can see that what JDOT is that, sorry, the input is a JSON object. So you provide a JSON object. And then how do I we have a new technology. I feel this thing needs to really be replaced by something like a Bluetooth or something. I feel more comfortable. All right, sorry about that. So how do I actually shuffle in in this case, is a comment object. The one I showed you earlier is thumbj for comment. Now is JDOT for comment. Let's actually look at the purpose here is a programming case. Okay, so what I really need to do is that I want to shuffle the information back to the C++ object. Let me actually take a look at this one. Okay, let me actually use this person object as an example. So if there is an author, this is the author of that comment. You can see that what I did is, let me actually go to person because this is recursive. You see that is actually calling the author's JDOT for that portion. But let's go to person.cpp and look for JDOT. Here is much better, cleaner, I guess. No, this is GPSDD. This is IP address. Okay, here is a person. So take a look. What I really did here is only this line. What I did is this vsId, that's the target, right? I want to push into the person object's vsId. How do I assign? This is the input, the pointer to the JSON object. And what I did is I just actually extracted this as an avatar name. So that's the key. So I use the object, and then I actually put the key, and then that will give me that particular field. Well, however, you see that this part is the only tricky part you need to worry about. Is there I have to say as string. So means that when I extract information from JSON, that the thing is that what is exactly the value the library is going to return to me is actually determined by what I put here. I can actually say as string, and I can say as int, or I can say as object. So essentially, I actually decide to how I want to interpret whatever the value field is because I know what to expect. So I have to say as string. You cannot just say without this dot as string because the compiler, the C++ compiler is pretty strong type. So you need to check whether the type you provide, it is the right type. Otherwise, it will say, okay, I think compiler is going to give you at least warning and maybe even error because there is a mismatch in terms of the data type. That's kind of one thing because JSON itself doesn't provide any type. It just provides you the representation, but you can check for type. That's why you need to put the as string. But I want to show you one thing which is important for JSON programming. I always have to do this because JSON, we typically don't know whether that particular value is there or not, because you can see that, for example, what happens if I have a person doesn't have a name, or I have a person doesn't have a vsId, or I have a person, or I have a comment without reaction. So JSON does not even, it represents an array, but it doesn't tell you how many elements that array really have. So you have to check. So that's why if you look at my code, I actually check for example, first one, when I check this JSON, I always check whether this is the null. If it's not null, I'm going to exit. But sorry, if it's null, I'm going to exit. And then I'm going to check whether this is an object. This has to be an object. If this input is not an object, means that it's a basic type, I'm going to quit as well. So after I've done this, I actually typically check this 4 things because I think a person JSON, now we're talking about parsing the JSON. I'm going to check whether those 2 elements are there, avatar name and vsId. If they don't have this 2, I'm going to quit as well. Look at the code I did. To check whether that particular key value pair is there is using this function called isNull. So I basically say JSON pointer and then provide the key value and then say if this is null. If it's null, then basically I will quit because it doesn't have information I'm expecting. And the second thing I'm doing this for, again, for vsId. And the other thing I can also check for type. I actually check if avatar name is a string or not. If vsId is a string or not. So essentially, I'm actually checking the things compiler is supposed to check at runtime when I'm actually dealing with JSON. Okay, so this is essentially how you need to extract the information. I want to share with you one more information regarding the array of this. Let's actually go to, then I have to go back to, I think it's comment.cpp. Okay, this part is handling array. So now I look at reaction. So again, I actually have to check reaction, whether it's a null, it's an object, it's an array. I actually have to check whether the data is array. So you can see here, my key value pair can go multiple depths. See, the first level, it is a reaction. If you remember that JSON I showed you last time. And inside here, there is a data. So how do you actually go in depth into a JSON with this style of programming? You're just using, looks like a multiple dimensional array. So in fact, you can do as many levels as you want. You can actually, if you know the structure of the JSON you're expecting, you can actually use this to go deep into that. So that's why in this case, I see that I'm using reaction and the data to key. So I'm actually jump two levels down in the key value pair. And then I'm expecting that to be an array. So I check whether that's an array. So you can see that there is 2 things I want to communicate here is that number one, you can just using this paradigm key value pair to traverse into any part of the big JSON you have. So number two is that I actually did a lot of check. Because when you write JSON program, that's a problem between JSON and C++. In C++, you have a compiler to help you to check all the data type. But in JSON, you don't even know whether that particular field exists in this JSON or whether this array, the format is consistent with what you believe. And therefore, you're going to receive some JSON, which is actually not the right JSON. So you provide a lot of check. Because if you don't check, believe me, that you're going to get a lot of null pointer and your C++ world will not be happy. Okay, so now I'm going to tell you how to traverse into an array. The way I go to array, you can see that I'm actually doing here. I'm actually extracting one reaction. So remember I have a reaction array. I'm going to extract one reaction JSON object, and then I'm going to convert that to a C++ reaction object. So this one is called JSON value LLV reaction. It's just, I call it L is a local, JV is JSON value, and it's a reaction. So that's why I call it LLV reaction. You can define whatever name you want. But here is our favorite pointer. The first key reaction, the second key data, you already know. The third key, just an index. If that is an array, then you can just use the index. So essentially, the whole thing before this J index is for you to reach that array of JSON. And then you just do J, then this will extract each of the object. And then guess what I do? After I have this LLV reaction, I just call JDOT LLV reaction. Because I know I already have a reaction object. I want to shuffle that, whatever, the JSON, that portion of the JSON array, I want to shuffle into the C++ reaction. I would just use this line. So this line is just for you to extract that. I mean, in fact, you can, of course, you can replace here with this, but it's too long. That's why I actually split it to make it more readable. But essentially what it is, here you actually extract that portion of the reaction JSON, and then you do new to create a C++ reaction. So this is a JSON reaction, this is a C++ reaction, and this line is bingo. You basically push this C++ into this, push this JSON, this is JSON, into the C++ reaction. Once you do that JDOT, then essentially you convert that JSON object into a C++ object. Of course, I check RC. By the way, many of you ask what is RC? RC is a return code because I want to make sure that everything happened inside that dump J is correct. If there is any error condition was detected, then the RC is not going to be 0. Okay, so basically I'm checking that as RC to check whether that process failed, that is actually okay. All right, any question? Yes. Right. Yeah. So there are two purposes. The purpose number one is actually to show you how to do JSON processing in C++. To say, how do I actually produce a JSON from a bunch of information? Right? You just shuffle key value pair. But the other one is that when you have this ugly, let me actually show you the ugly picture again. When you have a JSON, looks like this. Give it 2 seconds. Okay, so this is essentially a lot of key value pair with something which looks like they're unstructured. Looks like they're unstructured. It's essentially key value pair, but the thing is the value could be an object, could be an array. So therefore, how do I be able to extract information. What we really want to do is, for example, you want to find whether this person named Oracle has never liked a particular comment, right? I mean, you want to find that out. And how do you actually write the program to go through, to parse the whole JSON, to be able to extract that information? That kind of the programming, how do you do that in C++? And hopefully the library, I actually show you the example. It actually help you to. It's not just for processing homework 4, homework 5, 6. It's really in general, how do you actually handle the JSON value using the JSON CPP library. And number 2, I do want to say is that based on this paradigm, gradually, this is actually very important instruction objective, is that you need to have the capability, I believe so, every single object-oriented programmer need to have the capability to do this kind of object conversion. Means that you're actually handle object in one particular representation, one particular language. How do you actually be able to convert that to another word or another language? And that actually is a very practical, because you can think about the world is kind of interconnected right now, and people are talking different language, different programming language, different information representation. And how do I actually be able to make sure that this world will be able to talking to each other? That's the information you need to worry about. Okay, and that's to be honest with you, once you done it once or twice, that become a basic skill for you to master when you actually go out to really solve real world problems. All right. Okay, any question? All right, so I have about 12 minutes. So I'm going to talk about final project. All right, I'm going to start talk about final project. So I'm actually going to show you an example. Let me bring this. So this is part of the talk that I gave maybe a couple of years ago during the COVID, I remember. And the talk, by the way, the whole talk is still available on YouTube. I probably gave this talk July 1st, 2020. But I want to basically, so this is the talk I gave to International ASPER as well as National Science Foundation. And you can see that I'm actually using the system that we developed in ecs36b, which is the avatar name. We have a core, we have a vsId. So now you kind of see that where this is all coming from. So I'm actually going to tell you a computational platform. It's a little bit different from the computational platform that you have. So typically we believe all the computing, they should be connected to the internet. When you want to talk about JSON, you talk about shadow object. We're kind of assuming the computer or target are all connected with the internet. So I'm actually going to give you so let me high level tell you what I expect you to do with homework assignment. Sorry, not homework assignment. It's a final project. Is that I'm actually going to give you a computational platform which the computer you're going to interact with. So computers, okay, there are multiple of them. They're not connected to the internet. They're actually somewhere on campus. So initially, right now, I have 2 different nodes, but I hope by early December, I will have 10 nodes around the campus. So each of the nodes is a computer. It has a Wi-Fi for you to connect locally if you are closer to that. But each of this computer they don't have internet. They only can receive a response when you're close enough to the proximity of the Wi-Fi or Bluetooth signal. I mean, right now it's only Wi-Fi. So imagine this on the campus. We have a number. You can think about eventually UC Davis will have maybe we have 10,000 of this device for each of the dormitory, each of the instructional room, and each of this have this, but they are not connected to the rest of the world. They are not even connecting to each other. Everyone is a standalone device. But we assume that there is a way for you to install the server component of your computation in each of the component. I mean, I can tell you that what I'm going to do is that because there was only 10,000, I'm going to send somebody manually to just walk by each of the device and upload every new version of the program into that. Okay, so that is the given. That's a computational platform I'm giving to you. And my final project for you to do is that given this kind of constraint, I want you to design and implement an application that's actually going to utilize this kind of platform. In other words, let me actually tell you, today we're assuming we have the internet, but now I'm actually breaking that 101. I'm actually saying that you don't have the internet. You have the internet protocol, you have the internet programming, but you don't have the internetworking across the globe. And what kind of things you can do? What kind of application you can do with this platform? I'm going to tell you what's the advantage of this, but I want to first challenge you to think about final project. Think about it. Let me give you an idea. I want to play a game called Pokemon. So I'm actually install the Pokemon in some of the nodes, this 10,000 nodes, and you have to search for that. You have to have a clue on the internet side, and then you have to walk to that position and then retrieve that Pokemon. Okay, that's just one application. The other application could be, okay, I want to actually have an email service. And so right now you're using email address, right? But no, I'm not actually using email address. I'm using some kind of special address that the communicator, they know each other. And when I actually deliver the email, I'm not going to use a protocol called SMTP. I'm going to actually deliver that email to one of the box. So you must come to, for example, Professor Wu say, I don't take attendance, but I said the most important announcement or homework assignment is actually in the classroom. You have to come to this classroom using your smartphone or your device to actually retrieve that. So essentially, I'm forcing people, their activity into physical world to do this kind of computation. So you can think about that's just an application. For example, you can say this is a hiking trail in Yosemite. How many of you have been hiking in Yosemite before? Okay, a few of you. Do you think it will be convenient, say you're bringing your friends, but you're walking about half an hour faster, and then you can see, you can just check in one of this kind of disconnect component. You say, hey, I'm here, and I'm going to move in this direction. And the thing is that your friend who follow you half an hour behind, when they go there, they can actually check whether you're here or not, because you actually leave your footprint over there. So that's the platform. And I want to give you, the final project will be 4 students, at most 4 students, 3 or 4 is fine, or 2 in some rare case. And then you develop ideas and you provide an implementation that's actually allow your program to interact with this platform. And then you will be demonstrate with at least a few devices to see how your scenario will work. Okay, so that's the high level goal about the result. Sorry, what I'm going to ask you in final project. Any question? So let me actually tell you why I'm showing you this slide. So this is really initially motivate me. So you can see that when I'm doing this, the email example I gave, it actually kills most of the stem. Because no longer, if you actually have an email which with this kind of disconnect, it might be slower. Maybe you have to go to a certain place to actually get it. And maybe when I visit your dormitory, I'm actually not just visit you, but I'm carry all the email to that dormitory with my smartphone until, because I know a lot of people, I'm actually like a postman, a real postman in the 21st century, that I'm actually accumulate all the email that's actually directly to that instructional room or the dormitory. When I get there, the agent automatically figure out and then upload all the email to that device, and then the people, when they come home, they can actually treat the email. Think about that. That actually kill a lot of spam problem, because what's spam? Spam means everybody can actually do anything at any time. We try to put some restriction, and whether that is a good restriction or it's actually so we need to think differently in this example. So I have 3 minutes. I'm going to present this slide. So this is an example I start to argue. When you walk into a supermarket, the grocery store or whatever the store try to sell something to you. So the example is they saw this young man who actually walked to a point, and then he kind of, in front of the beer section, he kind of hesitated. He actually walked slow down. By the way, today's AI technology is very good. If you walk like this, and then you suddenly pay attention, your eyes contact with some of the product, the AI technology now will know that you have some interest in that particular product. So obviously, the company is going to issue you an instant coupon. When you do that, they detect that and give you a coupon. And the thing is, what do you get? You actually now, you got a 30% discount on a pack of beer. And that, of course, will trigger a sale. That's what a lot of Groupon, that's what Facebook is doing. When you are visiting some website, they try to analyze your intention and then try to send you all this nice information for you to buy that. Okay, now my question to you. Should in this case is Nugget, should Nugget issue this coupon to this person? I simply ask the question to everybody in National Science Foundation. I'm going to ask the question to you as well. Do you think Nugget should issue this coupon as a JSON, of course, to this person? Do you think they should? Yes. Okay, so here is what we want to, I'm actually, that's a good point, but let me elaborate what you're saying. So it actually depends. It depends on what? When this guy walk by, it could be he is really price sensitive, he's really interested in that, but it could be that he is actually addicted to alcohol. I mean, we don't know, right? It could be addictive, it could be, how do you say that? You could be just price sensitive. You want to wait for 30% to consume that product. In my opinion, the first one is a gray area. You can do that. But the second category is definitely no, right? But how does a computational system know you're addicted? How do you know? How do you think a computational system will know that you're addicted to alcohol? What? Sorry, I didn't hear it. You what? See how much alcohol it has. Okay, that potentially, but you can actually check his health record. And believe me that there is AI technology that Facebook and Google, they both have already. They're actually checking what website you visit, or you have to visit this particular, what do you call that, recovery center for a certain kind of issue. So they can access to all this information and then try to deduce whether this is the case 1 or case 2, and then they make a decision. I mean, just tell you personally that that's my research project right now. Not only looking at that, I'm looking at whether it's ethical to actually provide a pregnant woman to have a alcohol coupon. Because I need to analyze not just about the culture difference between whether a pregnancy should have any interference with the alcohol. That's actually itself is controversial. But also we have to look at the family relationship. Whether that person, whether in his family, his refrigerator, this are all triggered by Google's new project on smart fridge. You know that the Google next one big project is a smart fridge. So they're actually trying to using your smart fridge not as just a fridge, is actually a information collection potentially for your personal life. They know if you think about that, your refrigerator reveals a lot about what you have been doing. Okay, so that's the paradigm people has been working is I just collect as much information as I want, and then I figure out how to use that information. Okay, so now I go back to the project. So the platform I'm actually push you to do is a little bit different. It's like, yes, the grocery store in Nugget, they have a camera and they have some sensor to actually see your intention one way or the other. However, that device is not connected to the internet. That device is not connected to the internet means that let's think about, can we accomplish everything we just said without the internet, without a big company who is actually trying to collect all our information? That's why it's a privacy issue. So the story is, if that device seeing that I actually have some intention, he will contact with my smartphone. And now it's actually my control about how much information I would like to reveal. Whether I have a certificate to actually show I'm actually not the addiction person, and whether I have a health record, and whether I actually is under a culture which actually pregnant women is actually okay to, we consider it's a positive for us to have some small amount of course it will balance with other information. So essentially what we're saying is that with this infrastructure collecting all the information because they are all connecting, but the platform I'm giving to you at the end of the final project is a platform that those infrastructure is not connected to anyone. It's not connected to anywhere, but everything goes to your computation when you're actually close to that device. And then it's under your control. So essentially we're saying that all your information about your intention, I mean, I gave another example. This was a big argument when I was invited to that NSF project, is that they actually build the infrastructure to collect all the air quality results around the world and try to transfer this to one single place in Chicago, University in Chicago, and try to analyze the air quality. But what I'm saying is that why do you want to do that? Why don't you just have me carry this device to the air quality sensor to pull out information with me? So whatever air quality I experience, that I'm actually going to collect it. If I want to share with other people, that's my choice. But that's a different model about whether you want to. So I'm actually summarize the final project is giving you a bunch of computer physically distributed on campus. There's no internet connection. The only way you can connect is through a person walking around from device to device and to communicate. And of course, your device has internet. There is the internet on your phone, but there's no internet on those devices. So think about some ideas, start forming the team, and we continue cook this idea, okay? All right, thank you.